Okay, guys, today we're going to talk about proportional relationships and being able to determine whether or not a linear relationship is proportional. So, we're going to start with graphs because it's the easiest thing. And so, again, we're trying to find out if they're proportional. Okay, whoops, proportional. And if a graph is proportional, it should go through point zero zero. Okay, so if you take a look at this black line here, right here, it does not go through point zero zero. Okay, let's highlight point zero zero in purple. Let's change that color so we can make it a little more vibrant. Okay, so right here, point zero zero. The black line is a no. It does not go through point zero zero or the point of origin, so it's not proportional. The red line, if you look at the red line, it does not go through that point either. Okay, so we need it to go through this point, and if it doesn't go through that point on the graph, it's not proportional. So the red line is also no. Now, if you look at the blue line goes directly through the point of origin. And if it goes directly through the point of origin, you would say, yes, it is proportional. Okay, now we're going to look at tables. So let's look at how a table would look if it's proportional and how we would know. All right, so let's say I have this table. Okay, if I have this table, there are two ways to tell. Okay, the number one way and the easiest way is to just look if point zero zero is listed. If point zero zero is there, that means when you graph it, that's going to be on the line. So in this case, it would look like this. The line would be look something like this. Sorry, it's not so straight. It would look something like that, and it would go through point zero zero. So that would be yes, it's proportional. Now, if you don't have point zero zero in here, what you can do is you can make a proportion. So I'm going to set these two equal to each other. Okay, I'm just going to make them into fractions. So now it's 2 over 4 equals 6 over 12. And I'm going to use the butterfly method. And I'm going to multiply these numbers. So I'm going to multiply 4 times 6, and I'm going to get 24. And then I'm going to multiply 2 times 12 and get 24. And since they're equal, I would say, yes, it's proportional. Now, we might have something that looks like this. Oh, sorry. We might have something that looks like this. Not cooperating today. 4, 7, and 8, 2. Let's just say that. So if I have this, I'm going to make a proportion again. I'm going to make these into fractions, set them equal to each other, and I'm going to multiply. Now I'll multiply the 4 times 2 and get 8, and then I'm going to multiply the 8 times 7 and get 56. Since they're not equal, I would say it's not proportional. Okay, that's the easiest way to do that. Okay, if I follow the pattern back, let's follow the pattern back just so we can see if we could do that. Right, so this was, whoops, it was 4, 7, and I think it was 8, 2. So if I wanted to follow the pattern back, this is adding 4. So if I subtract 4 and go in the opposite direction, I would get to 0. Just following the pattern. Here I'm subtracting 5. So if I follow this pattern, I would add 5 and I would get 12. So I'm hoping you can see that pattern. It looks like this: 0, 12, 4, 7, 8, 2. On this side, I'm adding 4. And on this side, I'm subtracting 5. Okay. You can see that 0 is across a number other than 0. That means that this number is where it crosses the y-axis, which automatically tells me that this is not proportional. This would need to be the 12 here. That would need to be 0. If this was 0, then it would be proportional. There can be no other numbers across from 0 except for 0 if it is proportional. So anything other than 0, that would be a no. Okay? Now let's look at equations. This is not being cooperative today. All right, so let's look at equations and how would we tell if something's proportional or not proportional when you use an equation. So if you have an equation and it looks like this, or if you have an equation that looks like this, y equals 2x. Let's graph just so we can see it that way. So I'm going to create an xy table. And if I like to plug in 0, 1, and 2. And if I plug in 0, I get 3 times 0 plus 1. That's going to give me positive 1. And if I plug in 1, right, I got 3 times 1, which is 3, and 3 plus 1 is 4. And then I'm going to plug in 2, and I'm going to get this right here would be 6 plus 1, which is 7. Now, when we look here, across from the 0 is a 1. That should automatically be telling you that it's not proportional. When I graph this, I have 0, 1. Whoops. I have 0, 1, 1, 4, and 2, 7. And you look when I graph it, it does not go through 0.00. So you can see it here that it doesn't go through 0.00. Let me make it in red. You can see there that it doesn't go through 0.00. Here it doesn't go through 0.00. And on an equation, when it's in slope-intercept form, meaning the y is by itself, if we're adding a number here or subtracting a number, that means it doesn't go through 0, 0, because that is my y-intercept or where it crosses the y-axis. And since it doesn't cross at 0, it's not proportional. So this would be, this would be a no. Okay. Now let's take a look at this one. We'll do it in blue. So y equals 2x. So again, I'm going to do the same thing. I'm going to plug in 0. When I plug in 0, 2 times 0 is 0. And when I plug in 1, 2 times 1 is 2. And when I plug in 2, 2 times 2 is 4. So I'm going to plot those points 0, 0, 1, 2, and 2, 4. I'm going to graph that. It looks like this. And you can see, now we're looking here. Again, point of origin. It does cross to the point of origin. This is a yes. It does cross to the point of origin. In the table, you can see that it has 0.00 in it. That's a yes. And over here, since we're not adding anything, the y is by itself, so it's in slope-intercept form. We're not adding anything. That's because the y-intercept is 0. That's a yes. Okay, so on this side, this is a no. We're adding a number other than 0. Over here, it's a no because the number across from 0 is not 0. And on the graph, it does not cross the point of origin. And that's how we would find out whether or not it's a proportional linear relationship.